Alright, to get us started, we're going to go over some basic terms in Adobe Photoshop that can help you understand what the program is about before you even begin to open up the program. So we're going to start first with the most fundamental term, and that is the pixel. The pixel is a single dot of color information within a digital picture. Anything that you see on your computer is comprised of millions of these dots packed so closely you can't tell them apart. However, through the magic of Photoshop, we can show you an example. This is the ever photogenic Chris Bosch giving his best to try and photobomb the camera. But if I zoom in on his eye, which we're going to do right now, you will see that his eye, in fact, is comprised of millions of these tiny little squares of color. And these colors all blend together, and we'll go back so you can see it again. We will go to the previous slide here. You cannot distinguish one pixel from another here because they are so densely packed. But when we go back to zoom in, all of these pixels, all of these dots are individual, they're actually square, and they blend together when you zoom out so that you can't even tell that they're there. But each one of these pixels carries its own set of information about how much red, green, and blue makes up its color so that these pixels are represented properly. Adobe Photoshop is a raster-based program. Raster-based program means that it's dealing with physical pixels. Something defined as raster-based means that it's in a grid of pixels. Each pixel in the image has a color value, and altogether the pixels show the image. Attempts to enlarge images in a raster-based program means that original pixels will increase in either size or number. A low-quality picture will show poor quality when these pixels are enlarged, as the data is being spread over a larger area and, as a result, is easier to see. If there isn't that much information to begin with, zooming in or enlarging it is not going to help. Resolution is another word that you're going to come into contact with a lot. Resolution is the total number of rows and columns of pixels in an image. For instance, 1024 by 768. This is an example of image resolution. It means the image is 1024 pixels wide, width always comes first, followed by 768 pixels tall. The same term is used for computer monitors. So my monitor that we're recording on right now is 1920 by 1080. So 1920 pixels wide, 1080 pixels tall. That's otherwise known as 1080 resolution on TVs. Whether it's 1080i or 1080p, depends on how old your TV is, but for the most part, if we're on a computer monitor, it's 1080p. Resolution is also called dots per inch or pixels per inch, so DPI or PPI. These two terms are used like shorthand to assess an image's quality. For instance, if you told me that you made a 12-foot by 18-foot poster, a massive poster, but you only did it at 72 DPI, we're going to see how bad that looks when it prints, because there aren't that many pixels per inch. So it'll be kind of like we zoomed in a little bit. We will see little quality problems in between pixels. But at 300 DPI, which is good resolution, and 600 DPI and beyond, which would be high resolution, there's more pixels per inch, so it fools my eye into looking like a perfectly normal picture instead of seeing the individual pixels. With more pixels per inch, you can be certain that an image will enlarge better without looking bad. There are color modes in Photoshop that you will also need to know. RGB stands for red, green, blue. RGB are the three channels of visible light that we can see. All digital devices, phones, tablets, computers, TVs, they will show you color in mixtures of red, green, and blue. If you ask me, I have a little magnifying glass up front, and if you hold that magnifying glass over your phone, you will see the individual pixels on your screen. You will also see faint red, green, or blue outlines because the refraction of light kind of breaks that light apart into the RGB light. So you'll see some of that when you look at your phone. Values of color in RGB go from 0, which is black, to 255, which is white. There are three channels of color per pixel, so each pixel, in order to get all the colors in the rainbow, have a mixture of values of red, green, and blue. So if I have 0 red and 0 blue and 255 green, I'm going to have pure green. If I add red to it, I'm going to have yellow, and then if I add blue to it, I get white. As we play with the color picker in Photoshop, you'll sort of see how that works. CMYK is the other color mode in Photoshop, and that's what you use for printing. Cyan, magenta, yellow, and black. If you've got a printer in your house, take a look at that ink. It's going to be black, cyan, magenta, and yellow. In printing, CMYK mixes the four colors from above to make a color a printer can reproduce. However, CMYK should only be used in design when you are intending to print it. If I ask you for something that's going to be submitted online digitally, then you give it to me in RGB. But if you're going to do it for printing, you either need to proof it in CMYK or design it from scratch in CMYK. Colors are duller in CMYK. The expectation is to be printed on white paper, so the white paper enhances the brightness of the color on your sheet. RGB is designed to have vibrant colors for digital displays like smartphones, tablets, and monitors, so they're not as dull, because the idea is that you're going to be seeing it on a well-lit screen anyway. Layers are the most important thing to learn in Photoshop because the entire program focuses around this. And they work pretty much exactly like you'd expect. You place images on their own layers, and depending on the position of the layer in your stack of layers, you can see through one image to the other below. When you start erasing from one picture to reveal the one underneath, you can do some pretty interesting things. And here we go. We're going to put a picture of what's-her-name here, and it's on layer 1. And then we're going to add a picture of the interesting-looking Ron Howard on top of her, and now he's on layer 2. He's above her, so he's hiding what's underneath. But as I start to grab my eraser and go around with this document, you create this horrendous nightmare fuel that you'll see for years to come. And that's how layers work. He's on top. I've erased almost all of him. So you are only seeing the parts of him that weren't erased. They're just sitting on top of her face and hiding it and merging the two together. I really apologize for how long you're staring at this picture, but I really feel that you'll understand the concept the more horrified you get. Okay, moving on. Compression is another thing. Depending on how you save your file, you may compress the color of the pixels. And if you have a lot of variation in pixel color, compression will sometimes average those pixels together into one color so that it takes up less space. So compression reduces the file size of images. Compressed images are used on web pages to improve viewing speed and performance. Knowing compression can be very important. Depending on how you use the image can mean the difference between giving me an 11 meg file, because that would be great to print, it means it must be high resolution, or one that's like 303 kilobytes, that's 36 times smaller and ideal for the internet instead. Changing resolution is the most common way to resize an image, but compression comes from what you save it as. So you'll have different kinds of compression if you're in a GIF or GIF, depending on how you want to be on that argument on how to pronounce this, a JPEG, a PNG, etc. They all compress in different ways. PNG, for the most part, doesn't compress at all. So if you needed something that looked almost exactly like you designed it without any compression change, you use PNG. If you're going to sacrifice a little bit of quality so that you can get a preview out there, you'd use JPEG. And if you need to really smash down the size of this thing, then you're going to use the GIF or GIF format. Here we have on the left, this is an image that has very little compression, and here on the right we have an image that has a lot of compression. As you can see, colors have been averaged within little sectors here so that there's less color being shown in the document. When you zoom out, they more or less look the same, although if you study it closely, you can see the difference at regular zoom. And that reduces the file size, because if there's 1,000 different colored pixels making up this document, all that information is saved to your image file. So 1,000 different colors means a larger file. But if we can get away with this picture looking mostly the same, it takes up less space because we now have less pixel diversity. So we've sacrificed some of that 1,000 different colors down to maybe 300 or 400. The picture still looks mostly the same, and your file size doesn't inflate to gigantic proportions as a result. In Photoshop, you can use a variety of tools to select areas of a picture. A selection is an outlined area that contains all pixels within its boundary. A selection can be simple or it can be complex. Using tools like the lasso, the marquee tool, or the magic wand tool creates different complexity of selections. The lasso lets you draw a completely custom-shaped selection. The marquee tool lets you make selections as squares or circles, or as I call them, geometrics. The magic wand selects all of a certain color in one click. When an object is selected, a selection border appears around the selected area, as you can see on the left. When an object is deselected, the selection border disappears, which is what it would look like on the right. So what you have is, and this will be animated, and you'll see this in a future video, this is what they call the marching ants. Wherever your selection is, this will sort of move so that you don't miss the fact that it's actually there. Aliasing is another concept that you're going to have to understand, because sometimes you bring in a picture from the internet, it's going to have aliasing on it. And the reason why aliasing even exists is because if you remember back to the Chris Bosch picture, those pixels are made up of squares. So if I'm working with a solid color and I'm trying to make a curve, you're clearly going to see jagged edges as that curve starts to happen, because you can only make those curves out of square pixel edges. Aliasing is what's happening on the left, all those jagged edges. But on the right, we have what's called anti-aliasing. Anti-aliasing is the smoothing of jagged edges in digital images by averaging the colors of pixels at a boundary. Below, anti-aliasing appears on the right side A. Instead of jagged lines, the hard edge seems to fade into lighter colors. Instead of the edge running to black, it runs to gray, then light gray, then white to fade the edge. Any part of your digital composition that is completely opaque is something that can't be seen through. So opaque is the opposite of transparent. A wall is opaque, a window is transparent. In other words, opaque is the opposite, exact opposite of the word transparent. The amount of opacity in an image is inversely proportional to the amount of transparency that it has. So if that confused you, don't worry. Since opacity is inversely proportional to transparency, something with 85% opacity is 15% transparent, because it adds to 100%. Something 60% transparent is 40% opaque. So whenever you take from one, you add to another. So removing opacity adds to transparency. So if you want something to be exactly half visible, then it's going to be 50% transparency or 50% opacity, depending on if you're a pessimist or an optimist. Destructive versus non-destructive. In Photoshop, two terms get thrown around to describe a process in terms of how it affects your document. Destructive processes make actual physical changes to your pixels. For example, designing an RGB and then changing the document color mode to CMYK reinterprets the color values, and it's permanent. Erasing with the eraser is a destructive process. Making a selection and clearing it with the delete key is a destructive process. Those pixels are gone. Non-destructive, however, simulates processes or creates a temporary barrier between you and the actual pixels. Proofing is non-destructive. This allows you to simulate color changes without actually making them. Useful if you want to flip the switch back and forth and evaluate your color choices between RGB and CMYK. Masking allows you to cover an area with an invisible shield that you can add to or restore from. Just like taping over the molding at the bottom of a wall that you're painting, you're covering up an area that you don't want to get paint on. And then you could take that tape off and paint on it anyway if you wanted to. Adjustment layers allow you to add effects like gradients and black and white filtering without actually affecting the composition. These layers are a little bit tricky to use, but they are not permanent. You can go back and you can tweak how much color you want to remove with a black and white filter, or how much you want to enhance the black color tones of your picture, or how deep that gradient is supposed to be in terms of color if you're making a rainbow. Adjustment layers, for the most part, they are tough to work with because they affect every layer below it. No matter how you try to play with these adjustment layers, you try to put them in their own group, they will affect everything on your document that's below it. Remember that layers come in stacks. If my black and white adjustment layer is on the very top of the stack, everything below it is going to be black and white. So you got to be darn sure you know what you're doing. Otherwise, you may struggle trying to put it in the right place or get the right layers underneath it just to make it look right in your document. Okay, so these are the basics. We're going to go over these in class. Chances are you've probably already seen this in class, but in case you need a refresher, that's why this video is here. If you have any questions, let me know.